But the normal distribution, how can it help us? Well, we have identified how to get a sample mean, which is very informative, but it's just an estimate in one point. It doesn't give us with accuracy between what ranges the sample mean is going to be. In this case, we have a population, and let's say that we have identified our customer service rating from our sample, and it says that it's 4.4 out of 5. That is very good, but that is just 1 point estimate. The population might hold other numbers like 4.4, 4.5, 4.3. And to make decisions, we need to have more than just a point estimate. We need to have a sense of how close or far the true population might be from our estimate. So fortunately, we have the normal curve. This is also called the bell-shaped curve. So we can use the normal distribution to create a range around the sample mean that is very likely to contain the true population. The normal distribution is a probability distribution. There are others, but we're going to only see the normal distribution in this course. It is centered at the mean. It has certain characteristics that allow us to infer very useful information about the population. It also allows us to determine how confident we can be in our estimate. On the x-axis, we're going to have our variable. And on the y-axis, we're going to have the likelihood of that event happening. Let's take a look at women's height. Women's height will follow a normal distribution. That means that most women heights will be in the middle, where you see the likelihood it's taller because it's more likely to find women in this area. A few women will be on the short side and a few women will be on the tall side, okay? But most will be in the middle. The percent of all values falling into a specific range is equal to the area under the curve of that range. What does this mean? It means that all the women will fall within 100%, right? And then with the normal curve, we'll identify what percentage of women would fall between this height or less, between this height or more, or between X height and Y height. Later on, I'm going to show you how to use a couple of functions in Excel that use the normal distribution. With this function, we can identify, for example, if we know that the mean of the sample is 63.5, we would be able to identify what percentage of the women would fall at 61 or less. We could also identify what percentage of the women's height would fall between 61 and 66, or what percentage of the women would fall between 66 and above. We can do this because of the characteristics of the normal distribution. First of all, it's symmetrical. That means that the mean and the median are the same. That means that 50% of the women would fall below the mean and 50% would fall above the mean. That is useful. There are also other rules of thumb that I'll tell you in a minute. Another important characteristic is that the normal distribution will always look like a bell, but sometimes it will be taller or shorter. And how wide or narrow will depend on the standard deviation only. In this case, these two normal distribution have the same mean, but their standard deviation is different. The one in which the standard deviation is larger, it occupies more space. It's a little bit shorter, but wider. On the other hand, a normal distribution, same mean, but with the shorter, smaller standard deviation, it means that the values will be more concentrated in the middle. Therefore, it's going to be more narrow, a little bit taller. We have seen these rules of thumb already. We are going to use the mean and the standard deviation to make some interesting rules of thumb. The first one is that between the mean minus one standard deviation or plus one standard deviation, we're going to find 68% of the data. Between the mean minus two standard deviations or plus two standard deviations, we're going to find 95% of the data. And 98% of the data is going to be within the mean and three standard deviations to the left or three standard deviations to the right. If we're looking for outliers, they're going to fall outside of these ranges.